The naive-Bayes algorithm is supervised learning algorithm which is based on Bayes theorem and used for solving classification problems. It is mainly used in text classification that includes a high-dimensional training dataset. Naive-Bayes classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning models that can make quick predictions. It is a probabilistic classifier, which means it predicts on the basis of the probability of an object. Some popular examples of naive-Bayes algorithms are spam filtering, sentimental analysis, and classifying articles. Why it is called naive-Bayes? The naive-Bayes algorithm is comprised of two words, naive and Bayes, which can be described as naive and Bayes. Naive means it is called naive because it assumes that the occurrence of a certain feature is independent of the occurrence of other features, such as if the fruit is identified on the basis of the color, shape, and taste, then red spherical and the sweet fruit is recognized an apple. Hence, each fruit individually contributes to identifying that it is an apple without depending on each other. Bayes, it is called Bayes because it depends on the principles of Bayes theorem. Bayes theorem is also known as Bayes rule or Bayes law. This is the formula of Bayes theorem. There is probability A by B is equal to probability of B by A into P of A by P of B, where P of A by B is a posterior probability, probability of hypothesis A on the observed event B. B of A is likelihood probability, that is the probability of the evidence given that the probability of the hypothesis is true. P of A is a prior probability, that is the probability of hypothesis before observing the evidence. P of B is marginal probability, probability of evidence. So, working of naive-Bayes classifiers. Working of naive-Bayes classifiers can be understood with the help of the below example. Suppose we have a data set of weather conditions and a corresponding target variable play. So using this data set, we need to decide that whether we should play or not on a particular day according to the weather conditions. So to solve this problem, we need to follow some of the steps. First, convert the given data set into frequency table. Then generate likelihood table by finding the probabilities of given features. Now use Bayes theorem to calculate the posterior probability. So before going to see the advantages and disadvantages of the naive Bayes classifier, first we are going to see the example problem for naive Bayes classifier. So this is the working of naive Bayes classifier. Working of naive Bayes classifier. First, convert the given data set into frequency tables. Generate likelihood table by finding the probabilities of given features. Now, finally, we use a Bayes theorem to calculate the posterior probability. Okay. So see, this is the problem. If the weather is sunny, then the player should play or not. So to solve this problem, first we need to have a data set. Here some data sets are given for That is the 13 data. There is rainy, somebody says yes. Sunny, somebody says yes. Overcast, somebody say yes or no. So these are the data sets given here. First, we need to create a frequency table for weather conditions. So in this above data set, 13 data set of 13 informations, the frequency tables are created. That is weather, overcast, rainy, sunny. Here yes or no is given. So uh, overcast, 5 are say yes and 0% are said no. Rainy, 2% are said yes and 2% are said no. For sunny, 3% are said yes and 2% are said no. So totally 10% are say yes and 4% are said no. So likelihood table, weather conditions. Next, after created the frequency table, next we move to the likelihood table, weather conditions. So here also we have some category like weather, overcast, rainy and sunny. Here no means 4, yes means uh, 10. So out of this we have some conclusions. That is 5 out of 14. 14 information is given in the data table. There is 0 to 13. So 14. For overcast, yes said 5 out of 14. So 0.35. For rainy, uh, 4% said yes and no. There is 2 to 4 by 14, 0.29. For sunny, row wise, 2% said no and 3% said 3. So totally 5 by 14, 0.35. So column wise, the no said people for 4 out of 14 and 10 for out of 14. That is 0.71. So if you apply the applying Bayes theorem, P of S by Sunny is equal to, that is the formula. That is P of A by B is equal to P of B by A into P of A by P of B, like that. So here the P of S by Sunny is equal to 3 by 10. That is out of 10, we 3% said yes for Sunny, that is 0.3. Then P of Sunny is 0.35, that is 5% said yes as well as no, that is 3.5, that is P of Sunny. That is P of yes means 0.7, that is in this column, 0.71. So P of S by Sunny is, we must consider the S column, that is 0.3 into, that is S 0.3, the 0.3 into 0.71, that is called a Sunny column. 0.3 into 7.1 divided by 0.35, 0.60. So this is the sunny weather. Few persons have said yes, that is the value of 0.60. If you go for the no for sunny, again we need to apply the same formula, like P of sunny by no is 0.5, that is 0.5, that is out of 4 persons 2 said no, that is 0.5. Then P of no is gives 0.29. This is the first column. No given by 4 out of 40 people, so 0.29. P of sun is 0.35, that is overcast, sorry, sun is 0.35, that is 5 persons out of 14 said yes or no in sunny, that is 0.35. So if you apply the Bayes theorem formula, you will get the answer 0.41. So in this, if you consider these two, the above calculation, that P of S of Sunny is greater value of than P of no by Sunny. So hence a conclusion of sunny day is player can play the same game compared to the no set. So here from this conclusions, hence the sunny day player can play the game. So next, the advantages of Bayes classifier. Advantages of Bayes classifiers are, naive Bayes is one of the fast and easy ML algorithm to predict a class of data sets. It can be used for binary as well as multi-class classifications. It performs well in multi-class predictions as compared to the other algorithms. It is the most popular choice for text calculations problems. Disadvantages of main naive Bayes classifier is, naive Bayes assumes that all features are independent or unrelated, so it cannot learn the relationship between the features. The main applications of naive-Bayes classifiers are, it is used for credit scoring, medical data classifications, and real-time predictions, spam filtering, and sentimental analysis.